Dear students, welcome you all. I am Tavichellam, a faculty from EE department, and I am going to handle the subject transmission and distribution for second year EE students in fourth semester. So let's see the overview of the syllabus of this subject. You can see on the right topmost, it is given as LTPC, and L represents lectures 3 hours per week, and T represents tutorial, and P represents practical, so and C represents the credits. So the subject is a 3-credit course, and this subject is a core power engineering subject that focuses on how electrical energy is efficiently transmitted from generating station to consumers through transmission lines, substation and distribution networks. The course builds a strong foundation in understanding the electrical, mechanical and performance aspects of power delivery system. The objective of the course to impart knowledge about the configuration of the electrical power system, to study the line parameters and interference with neighboring circuits, to understand the mechanical design and performance analysis of transmission lines, to learn about different insulators and underground cables, to understand and analyze the distribution systems. Unit 1 is the transmission line parameters. So this unit introduces the structure of electrical power system and focuses on the electrical parameters of transmission lines. Students learn to calculate resistance, inductance and capacitance of single-phase and three-phase transmission lines with different conductor types such as solid, stranded and bundled conductors. The effect of conductor spacing, transposition, earth and skin effect and proximity effect are studied in detail in this unit. The unit also covers the application of self and mutual GMD and explains the interference between power lines and nearby communication circuits. The second unit is modeling and performance of transmission lines. This unit deals with the performance analysis of transmission lines by classifying them as short, medium and long lines. Equivalent circuit models and phasor diagrams are also used to analyze line behavior. The important performance parameters such as voltage regulation, transmission efficiency, surge impedance, attenuation constant and phase constant are also studied. The unit also explains real and reactive power flow, power circle diagrams, Ferranti effect and the formation of corona, including its critical voltages and impact on line performance. The third unit is sag calculation and line supports. This unit focuses on the mechanical design of overhead transmission lines. It covers different types of line supports and transmission towers used in power systems. Students learn to calculate sag and tension under various weather conditions such as wind and ice loading. The unit also discusses grounding methods and provides a detailed study of insulators, including type of insulators, voltage distribution in insulator strings, methods to improve string efficiency and testing of insulators. Fourth unit is underground cables. This unit introduces the design and performance of underground cables. It covers different types of cables and their construction, including single core and 3-core belted cables. Students study insulation resistance, potential gradient, capacitance calculation and grading of cables to improve insulation performance. The unit also explains power factor, heating effects and the characteristics of DC cables, which are important for modern underground transmission systems. Unit 5 is the distribution systems. This unit focuses on the distribution of electrical power to consumers. It covers AC and DC distribution systems, Kelvin's law and different types of loading such as concentrated and distributed loads. Techniques for voltage control, power factor improvement and reduction of distribution losses are also discussed. The unit also introduces types of substation and gives a qualitative overview of modern trends in transmission and distribution, including EHVAC, HVDC, and FACTS. The textbooks given are Power System Engineering by T.P. Kothari and I.J. Nagarath, Electrical Power System by C.L. Vatwa, and Electric Power Generation, Transmission and Distribution by S.N. Singh. The reference books are Power System Analysis and Design by B.R. Gupta, and Electrical Power Distribution and Transmission by Lucius M. Falkenberry and Walter Coffer, and the Power Transmission and Distribution by Arun Ingold, and fourth one is Transmission and Distribution by Brian Hardy and Colin Bayliss, and Handbook of Electrical Power Distribution by G. Ramamurthy, Principles of Power System by V.K. Mehta and Rohit Mehta, Power System Analysis by Hadi Sadat, a textbook of Power System Engineering by R.K. Rajput. The course outcomes. After successful completion of the course, the students will be able to understand the structure of power system, computation of transmission line parameters for different configurations. The student can model the transmission lines to determine the line performance and to understand the impact of Ferranti effect and corona on line performance. The students able to design transmission lines, grounding, and to understand about the insulators in transmission system, and also able to design the underground cables and underground performance analysis of underground cable. The student able to understand the modeling, performance analysis, and modern trends in distribution system also. With this, I conclude this session. Hope you enjoy. Meet you in the next section. Thank you.